A very warm welcome to this discussion on what's happening climate change in the power industry, where we'll aim to understand the impact of climate change on the power and electrical equipment industry and how industry is gearing up. My name is Vikas Gaba. I'm a partner with KPMG and I lead power and utilities for KPMG in India. I am joined by Vikram Gandotra, who is Director Industry and Policy at Siemens and is also President-elect at the Indian Electrical and Electronics Manufacturing Association, IMA. Welcome, Vikram.
Thank you very much, Vikas, for having me here.
So let me, Vikram, begin with a few pointers. Now, climate change is having a significant impact on the power and electrical equipment industry, affecting both the supply and demand for energy, and consequently the design of equipment, the operational characteristics, its specifications, and even performance. And few quick factors that come to mind. One, increasing demand for renewable energy. We know at COP28, world leaders agreed to triple renewable energy and double the energy efficiency by 2030. This, in effect, will create new demands on the industry like storage solutions, power inverters, whole range of smart grid equipments like RTUs, smart meters, communication equipment, and so on. Second is the infrastructure resilience. The climate events and severe weather events are happening. They are on the rise, and the industry will need to invest in more resilient equipment design systems which can withstand very extreme weather conditions and prevent failures. Third is temperature sensitivity. Temperatures are also on the rise. So the electrical equipment like transformers, generators, cable must withstand that heat stress, which causes overheating, insulation breakdown, lower efficiency, which leads to higher maintenance costs, short equipment cycles, and so on. Fourth factor is grid reliability and flexibility. With coming of more and more renewables, flexibility is the need of the hour. Next is the energy efficiency regulations itself, which are getting tightened, and there is need to regulate both on the consumption side as well as on the emission side. Raw material supply chain also get affected by extreme weather events, which can disrupt the mining and transportation of raw materials like copper, aluminium, rare earth elements, which can cause supply disruption to the electrical industry. And last is the increased electrification of uses, which in itself is increasing the demand of electrical equipment. So with this happening, all of this happening, and even happening at an unprecedented pace, how is the larger fraternity of electrical and electronics manufacturers looking at it, Vikram?
Thanks, Vikas. And it's a pleasure to be here on this conversation with you on such a relevant topic. The larger fraternity has recognized this trend, and being in the center of it all, it is gearing up for the transition. Here, the industry bodies and associations such as EMA, CII, FICCI have a very key role to play as they focus on climate change by promoting sustainable and energy efficient technologies. All these associations strongly advocate for the adoption of green energy, the integration of RE into the grid, the development of energy efficient electrical equipment, and also to enable all the members of these associations to play their important role in this whole process. And we encourage our members to use sustainable manufacturing practices also. Uh, Also, we are introducing products which are friendlier to the environment, such as SF6 free switchgears. Associations such as EMA collaborate with the government and international organizations to address climate change challenges, helping to frame policies that reduce carbon emissions and enhance the use of clean energy solutions. At the same time, there are events, workshops, and partnerships which are organized and developed to raise awareness amongst the members and all stakeholders about the importance of adopting climate-friendly technologies. As electronic and electrical industry, we play a critical part in addressing the climate change. So events such as ENRich, Elakrama are not only great to network, but also provide opportunities to learn, collaborate, and build solutions for the future needs.
Thanks, Vikram. That is really interesting to know. And in fact, just to deep dive into this, I would be keen to understand from you on the equipment side, especially, what are the changes you are seeing? One, in the nature of demand, the type because of this, the what is happening, the specifications, and how the even the use and performance of these equipments is being influenced. Can you deep dive with some examples into this?
Yeah, Vikas, thank you. So there are several changes that are occurring in the power and electrical equipment industry as a direct response to these challenges which are posed by the climate change. So, to give you some examples, I will bucket them into six buckets. The first being the development of climate resilient infrastructure. This includes things like storm hardened transmission lines using composites or other high strength materials in the towers and poles, which can better resist the high winds and corrosion. Even flood resistant substations in flood prone areas or coastal areas are being designed to prevent damage to them from rising waters by providing barriers and making sure that this critical infrastructure is always working. Second could be the grid modernization and smart technologies. Here we talk about smart grids, which includes using advanced sensors, automation, communication technologies to better manage the electricity flows. And today, almost all the countries have realized the benefits and are heavily investing in these technologies. AMI, which is advanced metering infrastructure, includes smart meters, and India itself is one of the largest, seeing one of the largest smart meter rollout program in the world, which is implemented on a special PPP basis. If I look at the third bucket, this involves the integration of the renewable energy system. With respect to the solar and wind energy expansion, which is unprecedented in history, the electrical equipment such as inverters, transformers, etc., they are being designed, or let me say redesigned, to specifically accommodate the fluctuating power output of these renewables. This bucket also includes hybrid RE systems, and for the high voltage side, we have technologies such as the HVDC line, the flexible AC transmission network, or what we call FACTS, and STATCOMs. These are very essential to integrate the renewables in our network. If I look at the fourth side, I would bring in the energy storage and battery innovations. Now, large scale battery storage has emerged as a promising area where there are a lot of developments which are happening. We are seeing the bid prices are progressively reducing in Indian market, and this is becoming more and more popular. OEMs are investing heavily in battery innovation, including new chemistries like lithium iron phosphate and solid state batteries. Another area, if I say the fifth area, would be the energy efficient equipment, like the energy efficient transformers. For example, transformers which use amorphous metal core. These are more energy efficient and generate less heat, leading to lower carbon emissions and operation cost. Then there is a question of voltage optimization. Electrical equipment is being designed with built-in voltage optimization capabilities, reducing energy consumption and preventing overvoltage, which can damage sensitive equipment and waste energy and resources. The last category would be the electrification and decarbonization of the industrial process, which is a lot dependent on fossil fuels. So this is a big emerging area and includes topics such as heating. Electric heating is becoming more useful. And many industrial processes are switching to other alternative options such as biofuels, hydrogen, which will also be using electricity and electrical equipment. Similarly, we are all seeing the rapid rise of electric vehicles. This leads to demand for power electronics, chargers, and grid integration solutions. So, if I say, I can say in the summary, as this market evolves, the demands are changing, and we see that the industry is also becoming more agile to meet these changing demands.
Thanks, Vikram. That was indeed pretty comprehensive in terms of bucketing and how you have captured it. So I'm very keen to take this forward and bring this to the theme of ENRich this year. The theme for this year is AI for energy, where we are talking about various dimensions of AI affecting the Indian industry, impact on workforce and jobs, impact on customer transformation, the social and policy dimensions of AI, how it influences like local entrepreneurship, resilient infrastructure. There are security and trust related issues, safety, transparency, and governance, and so on. We are seeing some really potent use cases of Gen AI that have the potential to significantly accelerate energy transition. And some of these we have been socializing in ENRich labs that happened through the year. Now, it will, of course, have steps. First, the AI solutions will take course and will start being deployed. Then the Gen AI applications take deeper form and expand. And then ultimately, combination of AI, quantum, and high performance computing solving complex energy problems. How do you see this aspect of AI, Gen AI, being induced into the electrical equipment industry? And how are these trends shaping up the industry? Vikram.
Yeah, so thank you again, Vikas. So this is very interesting, artificial intelligence and generative artificial intelligence, they provide a very key input to the whole development of new products and technologies. So we have seen that these technologies have started to influence the power and electrical equipment quite significantly. If I take some key use cases, say for example, the predictive maintenance and asset management, where the AI algorithms analyze real-time data from the electrical equipment such as transformers, circuit breakers, to predict potential failures much before they occur. So this has, of course, the benefit of increasing the reliability of the grid, but at the same time, the asset life also increases and maintenance cost comes down. Then there is a very big application in forecasting. Firstly, the forecasting for the load. Here, the AI models help to analyze the historical consumption data, the weather conditions at that point of time, and even social trends, which help the grid operators to make better decisions. On the generation side, again, there is a use case for forecasting where the AI model looks at the RE integration, predicts the availability of the RE energy resources by seeing what is the weather, cloud cover, wind speed, etc. And these help to make more reliable forecast on the generation. If you look at the energy management system here, the AI-based systems help businesses and utilities to reduce their energy consumption by analyzing usage patterns and seeing which are the areas where there are possible leakages. Demand response is another area which is very interesting, and this the application also sees configuration possible through AI. When we look at inverters, there are now smart inverters which will be AI powered, which can adjust the voltage and frequency of the electricity flowing from renewable sources into the grid and ensuring smooth integration and reduction of fluctuations. If we look at the manufacturing side, here too, AI driven tools have a lot of applications. We can generate optimized designs for equipment like transformers, switchgear, PCBs, etc., improving the performance and efficiency while reducing the material cost. Generative AI helps to explore thousands of generative design variations for the product, like heat exchangers, breakers, circuit boards, based on predefined parameters such as the durability requirements, weight considerations, cost consideration, and so it helps to design the products, prototype, simulation, and also the testing. So if you look at it, AI has applications in these emerging areas such as battery management solutions, fault detection, AI for consumer management and personalized energy solutions, for smart EV charging, even for supply chain management. This list can go on and on. The key point is that these technologies, they are evolving very fast and will continue to play an increasingly critical role in shaping the future of our energy sector.
Indeed, very well articulated, and in fact, completely agree. The list can go on, and the more we explore, the more we do with it, the more it throws back to us, and the cases are, I mean, infinite cases. So Vikram, thank you. It was great to understand and deep dive into how the power and electrical equipment industry is gearing up to meet the challenges posed by climate change, as well as the new areas like AI, Gen AI that are emerging. Thank you so much for this. And with this, we come to end of this conversation. This is Vikram and Vikas signing off.
Thank you.